Okay, so in the last couple of videos, we've been talking about different types of energy and the concept of transfer, or the concept of conservation of energy, which is the idea that energy cannot be created or destroyed in the universe, but it can change from one form to another. But when it does so, the total amount of energy stays the same. And so in the last video, we looked at writing like energy transformation equations, where an object might start with one type of energy, end up with another type of energy, but the actual values are equal to each other. Okay, and so in this video, we're going to start doing some calculations with energy, and then later on we'll see how we can combine the equations with the concepts we learned in the past video to solve more complicated problems. Okay, but in this video, we're just going to learn the basic equations for calculating different types of energy. Now, just to recap really quickly the types of energy we've talked about. Okay, so let's look at this energy checklist that you should have in your notes. And these are the questions you should be asking yourself when analyzing a situation to determine what type or types of energies exist in the problem. Okay, so first of all, is the object moving? If the object is moving, then it has kinetic energy, because kinetic energy is energy of motion. That's what kinetic means, is it means motion or movement. Okay, is there a spring or rubber band involved in the problem? Okay, if there is a stretched out spring or a stretched out rubber band, then that means there is elastic potential energy. Okay, so EE. Is there height above the ground? If you have height above the ground, then that object has a gravitational potential energy, which we write EG. Okay, if there is friction in the problem, if the object is moving and there is friction, then it's probably going to produce heat. It's going to produce thermal energy. And so for thermal energy, we write ETH. And we've not yet seen any problems when energy is being from a source outside the system. We will talk about that later. In those situations, you have what's called work, which we will write W for, and we'll do problems with work later on. Okay, now the types of energies that have equations, at least that we're going to be learning about, are going to be kinetic energy and gravitational potential energy. There are some equations for the other ones, but we're not going to talk about that, at least not just yet. Okay, so make sure you have this checklist down in your notes. We talked about in the previous video, but these are all things you should be running through when you're analyzing a situation so that you know what energy or energies an object has. Okay, so let's talk about kinetic energy first. Now, just to recap, kinetic energy is the energy of motion. Okay, so it's very simple. If an object is moving, it has kinetic energy. If it's not moving, it doesn't have kinetic energy. Okay, that's it. It has nothing to do with height. It has nothing to do with any other variables other than motion. Okay, or I guess to be more specifically, it also depends on the mass of the object. Okay, so here is the equation for kinetic energy. I'm going to write it down so that you can then add it to your notes. Okay, the equation for kinetic energy is EK, okay, so that would be kinetic energy, is equal to 1/2, and if you prefer to write 0.5, you can, 1/2 times m, m is the mass of the object, that's measured in kilograms, times v squared, where here v is the speed or the velocity of the object measured in meters per second. Okay, so kinetic energy is equal to 1/2 mv squared. Now, looking at the equation, you can see that there's basically two variables that affect kinetic energy, mass and speed, okay, or velocity if you prefer. You might see either of those terms, but either way, it's the same thing in this context. Now, what is the unit for kinetic energy? Well, any type of energy has the unit of joules. Okay, so it's named after a physicist whose name was Joule. And so for joules, we write a capital J. Just like for Newton, we write a capital N for the unit Newton because it's named after a guy. Now, what factor influences kinetic energy the most? So if you look at the equation, there's two variables in there. Now, mass and speed both influence kinetic energy because they're both in the equation. But which factor influences kinetic energy the most? Okay, well, that would be speed. That would be V. Now, why is speed more important than mass? Well, if you look at the equation, speed is being squared in the equation. Okay, so squared means it's being multiplied by itself. So in other words, it's really like 1/2 times the mass times the speed, then times the speed again. Okay, so you could make the argument that relay speed plays like twice the role that mass does in the equation. Okay, so that's the most important factor that affects kinetic energy. And you can see from the equation, if an object's at rest, that means if V is equal to 0, that means the whole kinetic energy equation is equal to 0. Okay, so make sure you have that equation down, and then we're going to do some basic calculations on the next slide. Okay, so let's take a look at example 1 and example 2. Okay, so example 1 is on the left. It says a 4-kilogram toy car travels along a tabletop. Calculate the kinetic energy if the speed of the car is 2 meters per second and then 4 meters per second. Okay, so again, kinetic energy equation, that's 1/2 mv squared. Okay, so at 2 meters per second, we want to calculate the kinetic energy. I read through, I identify my givens. I see 4 kilograms here, so that is mass, it's measured in kilograms. We're asked to calculate the kinetic energy, so that's the unknown. And then we're given the speed of the car is 2 meters per second, so that's going to be my v. Okay, so here's my equation. All I need to do is substitute and solve. So 1/2 times 4 times 2 squared. I multiply all that out. 2 squared is 4. 4 times 4 is 16. And half of 16 is 8. And so that would be 8 joules. Okay, now try to do the second part of example 1 on your own. Calculate the kinetic energy of the car if the speed of the car is 4 meters per second. Okay, so try to do that now. Okay, now there's two ways you could do this. Either you could just plug in the new speed, so 1/2 times 4 times 4 squared. Okay, 4 squared is 16, multiplied by 4 is 64, and then half of that is 32 joules. That's the answer you should have gotten. The other way to have done this problem is to do it like a proportional reasoning question. Okay, so we saw these types of questions in the last unit where basically say like, if I increase this variable by this much, how does the other variable change? So in this case, we know that the kinetic energy at 2 meters per second is 8. What happens if we double the speed? Okay, well, because speed is being squared in the equation, when we double the speed, it's actually going to quadruple the kinetic energy, which we can see it does because 32 is 4 times more than 8. Okay, so we also could have figured it out that way. All right, now example 2, we have the mass of the motorcycle. We have a 600 kilogram motorcycle, and we're told it has a kinetic energy of 12,000 joules. So here is EK. Calculate how fast. So how fast is always a question about V. The motorcycle is moving down the road. Okay, so I take my equation, EK equals 1/2 mv squared. I'm going to plug in, I'm going to substitute. So EK, I'm going to put in 12,000. That's equal to 1/2 times the mass, which is 600, times V squared. I can simplify this a little bit because I can actually multiply a half times 600 and get 300. And then I say what's being done to V, because I want V by itself, because that's what the answer is going to be. Okay, so the answer is going to look like V is equal to some number. So what's being done to V? It's being multiplied by 300. Okay, so I need to divide by 300 on both sides, because that's the opposite of multiply. And then I need to take the square root on both sides. So V is going to be equal to the square root of 12,000 divided by 300. And so I'm going to go into my calculator. I'm going to do 12,000 divided by 300, and then I'm going to take the square root of that number, and I'm going to get V equals about 6.32 meters per second. Okay, so that is the answer to example 2. Okay, so pause there if you need to look at that some more. Okay. Now, so that's it for kinetic energy. Gravitational potential energy also has an equation associated with it. So just remember that gravitational potential energy is energy that's stored in an object based off of its height above the ground. Now, the equation for gravitational potential energy is this: Eg equals mgh, okay, where Eg is the gravitational potential energy, m is the mass of the object, of course, and g is the acceleration due to gravity, whose value on Earth is approximately equal to 10 meters per second squared. Now, that's the same g that we've been using all year long. However, I do want to point something out because somebody always asks, wait, isn't it supposed to be negative 10? Okay, why are you making it a positive 10? So the answer is when we have used it as a negative in the past, the negative sign indicated direction because we were dealing with force or we were doing problems with acceleration. Both of those things have direction. Energy does not have direction. Okay, and so that's why we don't put the negative sign for this equation because the direction doesn't matter for energy. Okay, energy is a directionless value. Okay, h is the height of the object in meters above the ground. Okay, so very simple equation, we're just multiplying. Now the unit for gravitational potential energy, like any energy unit, is going to be joules. Okay, so looking at the equation, what factors influence gravitational potential energy? Okay, well, we have mgh. G, though, is a constant because that's the acceleration due to gravity. Okay, that's 10 meters per second squared. So really we just have mass and h, which is height. Okay, so pause there, make sure you have that equation down, and then we're going to do a few more examples. Okay, example 3. A 65 kilogram girl, right off the bat I label that as mass, sits at the top of a slide which is 2.4 meters high off the ground. Now I cannot draw. Okay, so imagine this is the slide like this. And so the girl starts up here, and this is 2.4 meters off the ground. Now we're asked to calculate the gravitational potential energy, so calculate Eg first at the top of the slide. Okay, so Eg equals mgh. Okay, so that would be the mass. Actually, so the equation is mgh. So m is 65, that's 65 kilograms. G is the acceleration due to gravity. Remember, that's 10 meters per second squared. And h is the height. So at the top of the slide, what is the height? Well, it's obviously 2.4 meters. Okay, so in my calculator, I'm going to type 65 times 10 times 2.4, and that's going to give me 1,560 joules. Okay, so that's the answer to the first part of example 3. Now, try to answer the second part of example 3 on your own. Okay, calculate the gravitational potential energy of the girl halfway down the slide. Okay, so same equation, but now when we go to plug in, the mass is the same and g is the same, but halfway down the slide is 2.4 meters high, and so halfway down the slide, the height would be 1.2. Okay, and so if you type that in, 65 times 10 times 1.2, you get 780 joules. And then example 3, at the bottom of the slide, same equation, but then you have to think, well, what is the height at the bottom of the slide? Okay, 65 times 10, but now at the bottom of the slide, the height is 0, and 0 times anything is 0. Okay, so at the bottom of the slide, the girl has no more gravitational potential energy. Now, does that mean that energy just disappeared into the universe? No, because energy is always conserved. It can only change from one form to another form. So in this case, that energy probably went into kinetic energy, and then if there was friction, a little bit of it probably went into thermal energy as well. Okay, so the energy, the number is the same. At the end of the problem, there's still 1560 joules. It's not Eg anymore. Okay, it's probably Ek or a combination of Ek and E thermal. All right, so pause there if you need to look at that some more. Okay, example 4. We have 14 kilogram monkey sitting in a tree that has 2,800 joules of gravitational potential energy. We're asked to calculate the height of the tree above the ground. Okay, so I want you to try to do example 4 on your own. Okay, so here's the equation. Try to do example 4 on your own. Okay, so if you plug in for EG, you get 2,800 equals the mass, which is 14. G is 10. Okay, then we have the height. I can simplify that. 14 times 10 is 140. 140 is multiplying the h, so I want to divide both sides by 140. Okay, and I get 20 meters. Okay, so that is the answer to example 4. Pause there if you need to look at that some more. Okay, the very last thing we're going to talk about in this video very quickly is what's called mechanical energy. Okay, so we talked about conservation of energy before. Okay, there's a new definition that we're going to learn, and that is called mechanical energy. Mechanical energy is very easy to calculate. E mech is mechanical energy. That is just the gravitational potential energy plus the kinetic energy. Okay, that's it. Eg plus Ek. Okay, that is what mechanical energy is. All right, so we're just going to do one simple calculation using that concept. So if you know how to calculate Eg and you know how to calculate Ek, you can find E mech pretty easily. And then in the next video, we'll learn about like why are we why are we calculating mechanical energy? We haven't talked about that yet, okay, but we'll come back to that later. Okay, so just to do a really simple example, we have a 45,000 kilogram airplane, so that's the mass, flying at a speed of 240 meters per second. That's V, okay, that's the speed, while traveling at an altitude, okay, so that's how high it is above the ground, of 2,000 meters. Okay, so there's H. Calculate the kinetic energy of the airplane. Okay, and so all of these individual calculations are pretty easy. This is just 1/2 mv squared. By the way, you are going to get very big numbers when you plug this in because, it's an airplane, it's pretty big, and also it's going pretty fast, so that makes sense. Okay, I get a number that looks like this: 129600000 joules. Okay, big number. Airplane's moving really fast. Gravitational potential energy. And see, each of these calculations we've done individually, mechanical energy is literally just putting it together. Okay, so now we multiply by the height. 45,000 times 10 times 2,000. And I get 9,000,000,000 joules. Okay, and then mechanical energy is literally defined as potential plus kinetic. Just adding those two numbers together. Okay, that's it. Okay, so if you do that correctly, I believe you should get 2196. Let me just change the mode of my calculator to make sure I got this correct. Actually, I'm going to do it in scientific notation. This is times 10 to the power 9 joules. Okay, and so I'm just going to double check my calculations really quickly to make sure I didn't do anything too silly. All right, and I think that is the correct answer. All right, so you should now be able to calculate kinetic energy, gravitational potential energy, and mechanical energy. Okay, and in the next video, we will do more complicated examples and calculations with these same concepts and these equations. As always, please let me know if you have any questions, and I'll see you guys in the next video.